Welcome to WXTV, your online source for weatherization training. To conclude our consumer education series on alternative energy options, we wanted to take a look at wind energy. And once again, Michael Goldschmidt will show us a simple home application down in Missouri.
I'm Mike Goldschmidt. I'm with University of Missouri Extension, Housing and Environmental Design. I'm here with Nicholas Peckham of Peckham and Wright Architects at his farm in Columbia, Missouri. Nick is one of the original green designers in Columbia, and it's a pleasure to be here today to talk to him about his wind turbine project. Nick, how you doing today?
Great, it's a wonderful day.
Great. So we have some questions we're going to ask Nick, and first of all, why don't you tell us a little bit about why you decided to put in a wind turbine?
Well, I think everyone knows that we have an energy crisis worldwide, and I believe that one of the only ways we're going to solve it is to have a lot of individuals do something in the world of renewable energy. So we started with a wind turbine. Yeah, we have a little 53-acre farm where Diane raises alpacas, and we grow some vegetables. We raise goats and chickens and give all our friends eggs and that kind of thing. Well, there are two factors that you consider when you're putting up a turbine. One is that you don't want trees too close to it, and two, the higher the better. So this isn't the very highest part of the property, but over there were trees. And so we put it here.
How tall is your tower here?
40 feet.
40 feet. And your decision to go 40 as opposed to higher or lower was to balance budget and height, or?
Well, there's a limit to how high you'd want to put a small, this is only a 2-kilowatt turbine. The really big tall towers that you see going down the interstate are enormous turbines and are able to take advantage of the expense of that kind of a tower.
How did you determine the size of your turbine?
Well, it was really a matter of budget. This was on the market. It's a SkyStream, and we could afford it, and so we did it.
And your turbine is the type that will change with the direction of the breeze, is that correct?
Right. It's a downstream turbine. If there's any wind today, it would be, the blades would be downstream of the wind. So it doesn't need a aileron on the back to align it.
This is an example of a turbine that is smaller than the one Nick Peckham has, and we've actually brought it down from the tower so you can see how small they are. These are called small wind turbines. They're usually recommended to be on a tower, but maybe not as tall as what Nick Peckham has. And you can see that this one actually faces the direction of the wind. And this will spin with the wind, and then it will rotate. And as Nick was talking about, that there is a tail fin in the back that and then helps it adjust to the direction of the wind. So we usually recommend for people that want wind turbines that they look at the smaller units that are able to spin faster when there's smaller wind and be able to rotate with the direction of the prevailing breezes. Now the smaller turbines, although they look better and are smaller and are less costly, will not produce the same amount of electricity as the large ones that we saw at Nick Peckham's. So we obviously have the tower, and as you mentioned before, we have it guy wired to these piers, and that's multiple purpose to hold it in place when it has strong winds so it doesn't collapse. And you also probably have lightning protection on this, correct?
I do. As you can see the wires right there. The guy wires also do another very important thing, and that is to keep the tower vertical, because even a little bit off vertical causes the rotational ability of the turbine to be compromised. And as you can see over here is the cutoff switch, so the electricity comes down to that disconnect, and then it goes right over into a separate meter into the house. Yeah, this is also a code requirement.
Okay. So.
And then underground we have, you can still see the shadow of the trench here where the wire was put underground. Like I say, it's underground. It comes to here, and it goes into a separate circuit breaker here, and then here's the wind turbine right here, separate disconnect for that.
So if you wanted to shut off the power, you could shut it off here. If there was an emergency, you could shut it off here from the house, but then to do maintenance to it, you would actually shut it off at the tower.
Either one, you can shut it off either place. And back here,
This is good.
this is the house meter that has been here ever since we built the house, and this is the meter for the wind turbine. We're grid tied so that in a nutshell, any electricity generated by the turbine is put right into the house, and therefore we're getting less electricity from the grid. They're both connected to the Boone Electric computer system so that they automatically know on a minute-by-minute basis what's going on.
But you could also look at this meter then and determine how much in kilowatt hours you had produced with the turbine.
Mm-hmm.
Okay. So you can compare the two meters to see how much the house is using, and the other meter to determine how much of that is being provided by the wind turbine.
Right, and Boone Electric gives me a report every month, not only for me, but other people who have renewable energy. We're all in this thing together and compare photovoltaics to wind turbines and so forth.
So between the wind turbine and the geothermal, you pretty much have reduced your energy load substantially.
Yeah, we spend about $100 a month.
And about how many square footage, and of course there's the farm operations on that too. So that's $100 for all the alpaca operations, the chickens, the vegetables, and the whole house. So
yeah, it's a pretty big house too now that it got expanded. This is an instant hot water heater.
Right.
So the only time we use any energy for this is when the water runs, because when the water goes through, it turns it on and you get hot water right away.
So is your wind turbine generating AC or DC power?
There's the inverter is in the turbine.
Oh, okay, that's interesting.
Yeah.
Because we're going to see later on inverters with the photovoltaics that are external. So you're saying in your particular brand of wind turbine, the inverters are in the turbine. That's interesting.
Right.
Okay. So when we were looking at the wind turbine system, we noticed that Nick Peckham had a wind turbine out in the middle of his yard, and then we saw that he had a disconnect that was right there at the wind turbine. That can actually be put inside the house if necessary, if the wind turbine is closer to the house. We also saw that Nick Peckham had an inverter which was inside the wind turbine, which is going to convert the direct current or DC power to the AC power that he would run his house. Now what we didn't see, which is a possibility for homeowners, is a battery backup system. Before it would go into the inverter, after it goes through the disconnect, it could go through what's called a charge controller. A charge controller regulates the voltage and the amperage of the wind turbine system so you wouldn't have a spike high or low. And the additional feature to that would be a battery backup. The batteries look like car batteries, although they're special batteries for a wind turbine system. So we would use those batteries, and there's usually 6 or 12 or 24 to hold that excess power for when it's needed, when it's not windy, and then they would be shut off when it is windy. And then it would go back to the inverter, just like we saw on Nick Peckham's property. And then it would go to the utility meter, which would be the same utility meter you saw on your house, but it would also be going to the electric company if they were buying back excess power, or to go to your house if you were using that power, say to run the dryer or the refrigerator or anything else that you use electricity for. So when we were at Nicholas Peckham's farm earlier today, we saw an example of a horizontal axis wind turbine. That's the one that most people associate when they think of wind turbines. This is a newer form of wind turbine, which is a vertical axis, which spins around the pole that's holding up the turbine. Now this one is spinning on a day with not a lot of wind, so the vertical axis can spin when there is not a lot of wind. However, they don't generate as much electricity. So one advantage of the vertical axis turbine is the turbine does not have to change direction with the direction of the wind. It will spin regardless of which direction.
Well, once a year we have somebody come and lower it and look at it and make sure it's okay, and that costs several $100s. Cost a little bit more this year because one of the guy cables got in the way of my John Deere brush hog and had to replace it.
And you had a professional contractor install this, so you didn't do any of the work yourself?
No, I didn't do any of it.
You probably would not recommend anybody doing it yourself because of the height and all the complexity of it.
Not only that, but you know, these concrete piers that are under the guy wires and the tower itself go 7 feet into the ground. So you know, it's a fairly serious situation. If you haven't done construction before, you might not be familiar with some of this stuff.
About what approximate percentage of your energy use on the farm is provided by the wind turbine?
On an annual basis, it's somewhere in the general neighborhood of 10%. You know, all summer it doesn't blow at all. And all summer we have large fans running in the barn to keep the alpacas comfortable. And every farm operation has a different energy requirement. As you know, we've also just put in a ground source heat pump, an instant hot water heater, and other energy saving things.
Could you tell us what the approximate cost of your wind turbine system was?
Yes, it cost a little bit less than $10,000.
Okay. And do you think it's possible for moderate income farmers to invest in this type of system in this area?
Well, the only thing you have to really be concerned with is wind. Wind turbines only work where it's windy, and as you know, Columbia is not as windy as the northwest part of the state, and so I think that would be the key factor for farmers to consider.
Well, that's it for another episode of WXTV. We've sure enjoyed doing this alternative energy series, and we hope we've given you some ideas of what's out there. Thanks again to Michael Goldschmidt for all his work on this project, and thank you for watching.